Welcome to another exciting educational video brought to you by Upvision Concepts Academy. Today we'll be looking at chemical combination. This is one of the most most tested topics in WAEC and JAMB chemistry. It includes bonding, mole concepts, bonding. Inside here, we have mole concepts. You have formulas, and chemical equations. So please, this is the foundation. This is the foundation. If you miss it at this point, chemistry will be very difficult for you to study. Okay? So we'll dive into the types of bonds. The types of bonds. Okay, so the types of chemical bonds. Types of chemical bonds. So I'm going to list them. Number one, I have the ionic bond, or we call it the electrovalent bond. And number two, we have the covalent bond. We'll look at them, look at the properties. Then number three, we have the metallic bond. Okay, so we're going to dive in straight and see this type of bonds and their properties. So we dive into the properties of ionic bond, or you can call it electrovalent bond. So the first thing we look at is state. What kind of state is it? Usually it's in solid state. The ionic or electrovalent bond is in solid state. Then for conductivity, it's in solution or molten. It's actually in solution form or in molten form. So when it wants to conduct, it has to be in this form. Okay. So the melting point for ionic or electrovalent bond is very high. Then the solubility is the ability to dissolve in water easily. It is very, very soluble in water. Examples of compounds that exhibit this kind of bond is sodium chloride. Sodium chloride is an example. Sodium chloride. You have manganese oxide. Then you have calcium chloride. These are basic examples of electrovalent bonds. And the thing about electrovalent bond is that there is a transfer of electrons from the metal to the non-metal. So you see that you have a metal combining with a non-metal. That this sodium combining with chlorine, this manganese combining with oxygen, and this is calcium combining with chlorine. So there's a transfer of electrons from this metal to the non-metals. So it's formed between elements with large electronegative difference. So you see this one at the extreme of the periodic table, chlorine at this side, sodium at the other side. Understand? When you see them combining, collaboration between one extreme or the left extreme where you have the metals and the right extreme where you have the halogens and the non-metals, then a ionic bond or electrovalent bond is formed. So note these properties, examples, and how it's being formed. Okay, so we go on to the properties of covalent bonds. For covalent bonds, each state is in gaseous or gases. It can exist in liquid or soft solid. For conductivity, unlike the ionic and equivalent bond, covalent bonds is very poor conductor. It's a very poor conductor. The melting point is from low to medium, and the solubility is very insoluble in water. Very, very insoluble in water. Examples of covalent bond are H2O. You know H2O now. Okay, not H2O. Let's say hydrogen. I'm just going to identify myself. Oxygen, methane, and carbon dioxide. So these are examples of covalent bond. You can have single, double, or triple bond. So that if you have, for like when we go to organic chemistry, you'll be seeing single bond like this for 2 carbon, double bond, and triple bond. So these are the kinds of bonds that can exist inside covalent bonds, and it comes because you are sharing electrons between non-metals. Non-metals are sharing electrons. You understand? You see that you have non-metals sharing electrons. So that is how covalent bond comes to be. So the last one we are going to consider is the metallic bond. Not much to talk about here. It's the bond between metal atoms. So in metallic bond, you have bond between metal atoms. Electrons are delocalized. So you see that electrons are delocalized. Examples of metallic bond is copper. Just you have copper like this. Copper is Cu, cupron. You have iron and zinc. These are examples of metallic bonds purely for metals. Purely for metals. So we'll move on to the next thing, mole concept and calculations. So we dive into the mole concepts and calculation. So the mole is the unit used to count particles in chemistry. So if you want to count particles in chemistry, we have a concept known as mole. So one mole is equals to 6.022 times 10 to the power 23 particles. Okay, so this is according to Avogadro. Avogadro is the scientist that did an extensive study on this. Avogadro's number. Okay, so this is the number. So 1 mole is 6.022 times 10 to the power 23. So molar mass is another concept. Molar mass is gram per mole. That's the unit. Gram per mole is the mass of 1 mole of a substance. Is the mass of 1 mole of a substance. That's for molar mass. Molar mass. The key formula to remember here is that the number of moles, number of moles is equals to mass in gram over relative molar mass. So you can just say num is equals to MIG over RMM. Just for you to remember this. Num is equals to MIG over RMM. Num is number of mole is equals to mass in gram over relative molar mass. Relative molar mass is actually a constant for all the elements. It will be given in your question. Another concept that you need to know is the concentration of okay, let me take this off so that you can have more concepts on the board. Okay, so I'll define the number of moles. Num is equals to mass in gram over relative molar mass. That has been defined. Another concept for you to know is the number of particles. Number of particles is equals to the moles. The moles times 6.022 times 10 to the power 23. Avogadro's number. Concentration. This is for stoichiometry. Concentration is mole per dm cube. Mole per dm cube. So it is the number of moles all over the volume of the substance. Volume of substance. Okay. Then we have the volume of gas. Volume of gas at STP. What's the meaning of STP? You can put in the comment section for me. The meaning of STP. Standard temperature and pressure. It's a condition for us to do this thing and get the answer the way we want to get it. Moles times 22.4 dm cube. 22.4 dm cube. So this is at STP. 22.4 dm cube is a constant. So these are the concepts we need to know, the formulas. I'm going to just go ahead and define the empirical formula. Empirical formula is actually the simplest whole number ratio of atoms in a compound. That's empirical formula, the simplest whole number ratio of atoms in a compound. That means a particular compound formed by atoms or elements. We just need to know the basics, the basic whole number. But the molar mass, the molecular formula is the actual number of atoms. The actual number of atoms, that's the difference. So again, empirical formula is the simplest whole number ratio of atoms in a compound. Just like making all this number of atoms in a compound to the lowest term. That's the way I will put it. But the molecular formula is the actual one. Okay, so let's dive into some calculations. Okay, so we'll look at the empirical formula, and these are the steps for us to get the calculation. The first one here is write down the elements and their percentage and mass composition. So sometimes they will give you percentage or mass composition. That's the first thing you do. Second thing you do is to write down each by their atomic mass to get the mole. So don't write down, just divide. Divide what you have here by their atomic mass or molar mass to get the moles. Okay? Then divide all the mole values from here by the smallest mole value. That's to get like a ratio or like a reduction. Then after that, multiply to get whole numbers if need be. Then finally write the formula using the ratio. So we're going to go ahead and apply this in a practical question. So take a look at these steps and internalize it while we try to bring up the questions for us to apply. Okay, so I have a question on the board. It says a compound contains 40% sulfur and 60% oxygen. Find the empirical formula given the molar mass. Molar mass in this my videos will be represented with capital M, while mass in gram will be small m. So capital M here is the molar mass. So from the guidelines I gave you, the first thing you do is just write the element. Let me just do a table to show the step from first to the last step. So I'll just do a table, very simple. The first thing to do right are the elements. I have sulfur and oxygen. The next thing I'll do is to write down the percentage composition. This is sulfur is 40% and oxygen is what? 60%. The third thing I'll do is to write out the molar masses, get the moles. Yes, get the moles. Let me put it like this. The moles. I know that mole is equals to mass in grams, small mass over molar mass, or percentage composition over molar mass. So this percentage is 40 divided by molar mass is 32, right? Okay, let me just put it in one line so that you know. 40 divided by 32. So what it will give me is approximately 1.25. And for this one, I have 60 divided by 16. What it will give me is 3.75 approximately. So that's the third step. And the first step is to divide by the smallest. Divide by the smallest. What is the smallest here? The smallest is 1.25. So I say 1.25 divided by 1.25 again. Sorry, 1.25 again. It will give me 1. And 3.75 divided by the smallest again, 1.25, will give me approximately 3. So I have two ratio. My ratio is 1 and 3. So I'm going to write the formula based on this ratio 1 and 3. So sulfur is 1 and oxygen is 3. So I have 1, I don't need to write the 1 here, then 3. So this is the empirical formula. The empirical formula for this question. And you know, it depends on the condition, depending on the mass combination or percentage combination that is given. So let's go into another one. See, it's 5 steps, 1, 2, 3, 4, and 5. Okay, let's go into the next one. Okay, see another one on the board. It says a compound contains 75% carbon and 25% hydrogen by mass. Find its empirical formula. Find its empirical formula. Okay, so what we do here, I will do the table again, so that I can just show the 5 steps. I cannot show the 5 steps one by one. The first one here is to write out the element. Write out the element. So I have carbon. I have carbon, and I have hydrogen. Okay. So the next thing is to get the percentage composition. For carbon, I have it at 75%, and hydrogen is 25%. Note how the two combination will give me 100%. Okay. So the next one is to get the number of moles. Number of moles. Moles is equals to mass in gram, small m over big M, or percentage composition over the molar mass. So percentage composition here is 75 divided by molar mass of carbon is 12. That will give me approximately, let's see, by the time you divide 75 by 12, what do you get? We might not get an absolute value. We'll get like a 6.25. Okay, 6.25. Then by the time you divide 25% here by the molar mass of hydrogen, which is 1. What is the lesser ratio here? The lesser ratio is 1. So I would say divide by smallest. Divide by smallest. So what is the smallest here? 6.25 divided by 1 is still 6.25. And 25. Okay, sorry about that. The smallest here is what? 6.25. Okay. 6.25 is smallest, right? Divided by 6.25, yes, again. Which will give me 1. And 25, sorry about that, 25 divided by 6.25 will give me approximately 4. Okay, so I have 1 and 4, right? So the ratio here, I have 1 here, and I have 4 here. So I have split it. Carbon is 4, hydrogen is 1. So my empirical formula is carbon is 1, then hydrogen is 4. So this is the empirical formula for this particular question. So molecular formula actually shows the actual number of atoms each element should possess. You know, empirical formula is said to be that you have the least representation, as in the smallest ratio, like the lowest term. But the molecular formula is actually the amount, the how it is chemically constituted. Understand? So it is the multiple of the empirical formula. So molecular formula actually is related to the empirical formula this way, n times empirical formula. Empirical formula. That's how it's related. Empirical formula. My word. Empirical. I hope I get that right. Empirical. Okay, empirical formula. Okay. So What is N in this relationship? So N is the number of moles, which is equals to the okay, well, N from here can be molecular formula all over empirical formula. That's making N show the formula. Okay, empirical formula. Okay, so we're going to dive in quickly to get this right. I just want to let you know that empirical formula, that this N is number of mole. Okay, let's dive in to solve some questions. So I have this on the board. Say a compound has an empirical formula CH, that is carbon and hydrogen combined, and molar mass is this, that's 78 grams per mole. What is the molecular formula of this compound? So the first thing we'll do is to find the mass of the empirical formula. This empirical formula CH, what's the mass? So mass of empirical formula is equals to, I'm going to be adding the individual masses, molar masses, 12 plus 1 is equals to 13. Now, having gotten the mass of the empirical formula, I will now find the number of moles, the number of moles of that empirical formula. And the formula for that is N is equals to 78, because this is the mass in gram per mole over this 13. It will give me 6. So if N is 6, I'm going to multiply N by the empirical formula. Okay, so I'm going to multiply N by, so molecular formula is equals to N times empirical formula. So my N here is 6. Empirical formula is C and H. So 6 times C is C6, and 6 times H is H6. So this is the molecular formula of this compound. Molecular formula of this compound. So we check another example. Okay, so we have this question on the board. It says a compound contains 24 grams of carbon, 4 grams of hydrogen, and 32 grams of oxygen. If the molar mass is 60 grams per mole, find the molecular formula. So the first thing we'll do is to find the empirical formula, because we know that molecular formula, that's by calculation, formula is equals to N times empirical formula. Okay, so we don't have empirical formula yet, and we don't have number of mole, but we can get this one and get this one. Now to get empirical formula, I'm going to take this one, C, H, and 0. First of all, I'm told that carbon is 24, hydrogen is 4, and oxygen is 32. So I divide each by the various molar mass, you understand, to get, this is 2, this is 4, and this is 2 again. So 2, 4, 2. So the simplest ratio is 2, 4, 2, right? Or I can reduce it to 1, 2, 1. The simplest ratio. So the empirical formula is C, H, 2, 0. This is empirical formula. So I've gotten this one now. But I'm looking for N. So to get N is simply number of moles, right? Number of moles. And number of moles is the mass in gram, this one, 60, over the molar mass. Molar mass now is the mass of all this one combined together. So I have the mass here, 12 plus 2, because there are 2 here. 1 times 2 is 2. So 12 plus 2 is what? 12 plus 2 is 14. 14 plus 16 here is 30. That's why I have 30 here. So mass in gram over molar mass will give me number of moles. N is equals to 2. So I haven't gotten N as 2. I can now put it in this formula, molecular formula. So molecular formula is equals to N is 2 times CH20. So this time this will give me, oh, let me just write it here. 2 times C will give me C2, and 2 times 2 here will give me H4, and 2 times 0 here and 1 here will give me 0, 2. So this is the molecular formula of this particular compound in this kind of situation. Okay. All right, so we'll go on to the next one. Okay, so I will just quickly look at these two WAEC-style practice questions. The first one says, which of the following is a covalent bond? Okay, based on what we learned in this topic, covalent bonds are formed between the extreme left metals, alkali metal or alkali metal, with the extreme right end halogens. So this is electrovalent bond, this is electrovalent bond, and this is electrovalent bond. But the correct answer for this question is C. It's called covalent bond. Why? Because I have this halogen and hydrogen. This is really not a reactive, extremely reactive hydrogen combining with the halogen. So that makes it a covalent bond. Then for the second question, it said calculate the number of moles in 44 grams of carbon dioxide. Okay. Carbon dioxide, please. We said that number of mole M is equals to mass in gram. So I can say small m over big M. Mass in gram over relative molar mass. I'm giving that my mass in gram is 44 gram, and my relative molar mass is 44 gram per mole. So this will cancel this. So I have number of moles is 1 mole. So 1 mole is the answer. 1 mole is the answer. So in summary, just try to understand bonding types, how to classify compounds. Please understand that. Go through the videos, go through your materials again. Be confident in mole calculations, empirical formula, molecular formula. Then practice past WAEC questions regularly. So please subscribe to our channel. There's still one part of this topic we have not dealt with, which is balancing chemical equation and stoichiometry. So in subscribe, when that video comes out, you'll be first to get it. I hope this video has been informative for you, and I'd like to thank you for viewing.